In this video, we're going to start talking about factoring. So last week we worked on distributing, multiplying, when we were either distributing a single term or just multiplying two binomials and then a binomial and a trinomial. So this week and next week, we're going to be actually working backwards from that multiplication process. So what we're going to be trying to figure out with factoring is what was multiplied together to give us this particular expression. So it's kind of backwards work of all the multiplication that happened in 8.1. So when we are factoring polynomials, the first thing that we always have to check for in every factoring problem is a greatest common factor. And a greatest common factor is going to be the largest thing that every term is divisible by. So for your coefficients, it's the largest number that each term is divisible by. If there is a variable involved, it's going to be, what variable do we see in every term and how many of them do we see? And I'll get into more details of that when we start actually finding those greatest common factors. So we have to check for that first. Once we find that, if there is one, and a lot of times we'll shorten greatest common factor to just GCF, we're going to factor by dividing that out, basically. So we're going to end up dividing each term by that greatest common factor. So let's look at some examples to see what in the world all of that means. So here's our first expression, 3x squared minus 9. So the first thing that I want to look for is I want to know what number is the largest number that both 3 and 9 are divisible by. And that number is 3. I also want to see if my greatest common factor is going to have a variable with it or not. So I'm going to look at my two terms and see if they each have a variable. Well, the first term, 3x squared, has an x, but the 9 does not. So they have no variables in common, so my greatest common factor has no variables. So my greatest common factor is just 3. And so in order to factor that out, I am essentially dividing each term by 3 to figure out what would have been inside those parentheses before I distributed and got 3x minus 9 as my final expression. So the greatest common factor is going to go in front, and then in parentheses we're going to put what we get when we do this division. So 3x squared divided by 3, well, 3 divided by 3 is 1, and that just leaves me with x squared. 9 divided by 3 is 3, so it's minus 3. So when I was talking about working backwards, last week you were starting with things like this, and you were simplifying, you were multiplying or distributing the 3 times the x squared, 3 times the negative 3, and your answers looked like this. So now we're basically undoing the work that we did last week. So rather than having things in their simplified form, we're putting things in their factored form. In this next problem, we need to think about the largest number that both 25 and 35 are divisible by, and that number is 5. Because both terms have an A, even though the font is different, sorry about that, they're both A's, A is going to be part of my greatest common factor. And to determine the exponent on A, I just want to see what is the lowest exponent of A. Well, this is a squared, this is a to the first, so my greatest common factor has that lowest exponent of just 1. So to put it in factored form, I have the 5a in front, and then in the parentheses I'm going to put what I get when I divide each of these terms by 5a. Well, 25 divided by 5 is 5. A squared divided by a, subtract those exponents, leaves me with a. Minus 35 divided by 5 is 7. A divided by a is 1, so I don't need to write it. So that's my final answer. You can always check these by multiplying them out and making sure you get right back where you started. This example, the greatest common factor between 2 and 14 is 2. Both terms have an x, and the smallest exponent on the x is 3. So my greatest common factor has an exponent of 3. So that's what I'm going to be factoring out of each term. I'm going to be dividing each term by 2x cubed. 2 divided by 2 is 1. I don't want to write that because it might just be a coefficient, so I'm going to wait and see if I have any x's left. X to the 4th divided by x to the 3rd is x, so I don't need to write the 1 because I don't write coefficients of 1. 14 divided by 2 is 7. I already gave that one away. And then x to the 3rd divided by x to the 3rd, those will simplify to just 1. They kind of cancel out, as we might say. So that's my final answer. We do the same process even when we have a trinomial here. So we look at all 3 terms and figure out what is the biggest number that goes into 2, 12, and 18. And the largest number that goes into all 3 of those happens to be 2. And I look to see, does each term have a variable? Well, 18 does not have a variable, so that's not something that they all have in common, so my greatest common factor won't have a variable. So I'm going to be factoring out a 2. I'm going to be dividing everything by 2 to figure out what goes in the parentheses. So here, 2y squared divided by 2, these simplify to a 1, and I am just left with y squared. Minus 12 divided by 2 is 6, and I still have the y, and 18 divided by 2 is 9. So this is kind of your process when there is only one variable, whether it's 2 terms or 3 terms. In these next 2, we're going to look at what in the world are we going to do when we have multiple variables. So I still look at my coefficients the same way, and I think about what is the largest number that goes into both 17 and 51. 17 actually goes into both of those, so my greatest common factor is going to have a 17 in it. And then I'm going to look at each variable independently to determine which variable or variables are in my greatest common factor. So when I look at these, both terms have an x, so my greatest common factor will have an x, and the smallest exponent on the x is this one right here, the 1. So my greatest common factor is x to the 1st power. Both terms have a y, so my greatest common factor has a y, and the smallest exponent on the y is 3, so my greatest common factor has a y to the 3rd. Only the first term has a z, the second one does not, so that's not something that's in common. It's not part of the greatest common factor. So I put my greatest common factor in front, and then in parentheses, I'm going to put what I get after I divide each of these by 17xy cubed. 17 divided by 17 is 1. I'll probably have some variables here that I'm not going to write the 1. I don't need that as a coefficient. X divided by x is also 1. Y to the 4th divided by y to the 3rd leaves me with a single y, and the z didn't go anywhere because we didn't divide by any z's. 51 divided by 17 is 3. X squared divided by x is just a single x. And then y cubed divided by y cubed, those cancel out, so that last term is just that. Now, we have to make sure our answers are in... I just realized there's an error on the answer key. All right, so I'm going to have to fix the notes for you guys. So I also have to make sure that my final answers are in standard form. And so standard form for this inside part right here means that I need the terms to be in alphabetical order. So I actually need the term with the x to be the first term because it comes first in the alphabet. And then the yz term is going to come second. And I still have the 17xy cubed out in front. I'm just looking back over the problem to make sure I didn't make a mistake in the video. And I did not. All right, so I'm going to fix the notes key so by the time you guys pull it up, it will be corrected. All right, let's go on to this next one. So the greatest common factor between 9 and 27 is 9 itself. Both terms have an m. The lowest exponent on the m is 2, so my greatest common factor has an m squared. Both terms have an n, and the lowest exponent is a 3, so my greatest common factor has n cubed. The greatest common factor goes in front, and then I'm going to be dividing by that to find out what goes inside the parentheses. 9 divided by 9 is 1. Not going to write it because most likely there will be some variables. So m to the 4th divided by m squared leaves me with m squared. Just subtract those exponents. N to the 5th divided by n to the 3rd leaves me with n squared also. Minus 27 divided by 9 is 3. And in this one, I see that it's m squared divided by m squared. Those cancel out or equal to 1. And n cubed divided by n cubed also cancels out and is equal to 1. So there is no variables on that last term. Double checking to make sure it's in standard form, and it is. I can't say it enough. Make sure your final answers are in standard form, so alphabetical order, and within each letter of the alphabet of your variables in descending order of exponents. The original problems are not always going to be in standard form, so do check for that with your answers. Alright, so that is the end of our video for A. A few other things to talk about that aren't in any of these examples are that if all your terms had a negative would be part of your greatest common factor. So another thing that you want to find is that the part that is left inside the parentheses, you actually want that leading term to be positive. So sometimes your greatest common factor will have a negative just so that that first term is positive. Other times it might have a negative because all the terms were negative, but those are some general things you're going to see, especially if you're working on the spicy assignment that practices this. Be aware there are going to be times where your greatest common factor needs to include the negative, either because every term has a negative or because you need your leading term to be a positive, leading inside the parentheses here. So to practice this skill, you need to choose at least one assignment from the top row of the choice board. This is a week where it is important that you choose things from both rows because you need to practice the skills that we're learning in both Lesson A, which was this one, and then what you're going to learn in Lesson B. Do not go on to Lesson B until you have practiced Lesson A and you feel really confident with it.